Modern Physics by Charles E. Dole. This was Marvin Carter's book. I got this at a secondhand store, the St. Vincent de Paul secondhand store in Port Orchard, Washington. Copyright 1939. This is a 45 edition, I guess. Few subjects touch a person's life so closely as elementary physics. No subject is better fitted to develop the reasoning powers or to stimulate that uncommon faculty known as common sense. From the time a pupil opens the water faucet in the morning till he snaps off the electric switch upon retiring, he is constantly applying or observing some principle of physics. These principles may be connected with the airplane, the automobile, or television. They may have to do with the more prosaic wheelbarrows, bucksaws, or garden tools, or they may be related to football, baseball, or some other sport. In the writing of this textbook, the author has practiced the following method of approach. 1. The topic is stated or a question is raised. 2. Some incident with which the pupil is familiar is used as an introduction. 3. The physical principle is then discussed or explained in language simple enough for a beginner to understand. 4. The manner in which the principle is utilized is shown by the use of one or more applications. Such a method arouses interest by its inductive approach. It is understandable because of its simplicity. It links the principle with the pupil's former experiences. It is practical because it introduces so many appliances which the pupil meets from day to day. Many of the illustrations are line diagrams. They are used abundantly because they generally prove to be better teaching aids than half-tones. For example, one finds it difficult to explain the operation of a gas engine, a steam engine, or a dynamo from photographs. With a line drawing, one can emphasize the important details. Halftones, which are also used abundantly, give a good idea of the magnitude and the scope of the machines used in the applications of physical principles. All right. That's how Mr. Dole's preface. I'm not going to go through the whole preface. We'll get to the part that's interesting here. Well, start at the back, like we always should, right? Back to the front. I showed my friend my centripetal farce video, where I was talking to him about it, and I remember, and then later on I remembered I had this textbook, so I thought, oh hey, I should look up centripetal force in there, centripetal, and so I tried to, and what I found is, the illusory fantasy illusion of centrifugal force, it's in here, but the real force, the centripetal center-seeking force, is not. I thought that was strange. See, here's the get that in the frame. Okay, here it is. See, we go from centimeter, centrifugal, centrifuge, Chadwick, center of curvature. There is no centripetal anywhere in here. No centripetal. A couple mentions of centrifugal, which, for something that doesn't exist, that seems odd, right? Let's see what they have to say about it. It's under the heading of curvilinear motion and centrifugal force, that non-existent force that's an illusion, science asylum. How is curvilinear motion produced? From Newton's first law, we learned that a body which has acquired velocity continues to move in a straight line. If a second force acts upon the moving body at right angles to its path, it will be deflected from its rectilinear line, and its motion will become curvilinear. To illustrate, we may tie one end of a string to a ball. Holding the other end firmly, we may swing the ball in a circle about the hand as the center. The pull of the hand upon the cord deflects the ball away from its rectilinear path and towards the center. So the pull of the hand is what's keeping the ball on a curved path. The pull of the hand representing centripetal force is what the claim, I guess, is. Moving right along. See figure 211. It's pretty easy to picture that. So, as the ball moves along the circumference from B to A, the pull toward the center has deflected it a distance equal to AO. The constant pull that deflects a body from its rectilinear path and compels it to move along a curve is called centripetal force. Centrum, center, petra. That's the only place that it mentions it. It's not in the index. I just thought that was strange, but it is mentioned in here. But the force that is so adamantly stated as being not real and imaginary is listed in great detail. What is centrifugal force? Centrum, center, and fugere, to flee from. If the revolving body of figure 211 did not have inertia, it would be pulled to the center. That's a difficult statement there because, right, I don't think so. If it didn't have inertia, it wouldn't be moving, and then it wouldn't be it wouldn't be creating any forces upon it. Okay, anyway. If the Earth, and then it immediately goes into if the Earth revolving around the sun did not have inertia, it would fall into the sun because of gravity, of course. So we've established that inertia and an outward pull is a thing. The reaction due to the inertia of the moving ball offers resistance to the centripetal pull and tends to break the string. What are they saying right there? Because I watched several videos about how centripetal's real, centrifugal's an illusion, and that's the end of the story about those two. We're just misinterpreting the way we feel. The centrifugal force is not real, it's centripetal. And I got some problems with their explanations or their examples. They poked holes in most of their examples that I've seen so far. But this old book here is like having to stick somewhat to, the truth. I mean, there's some Newton references in there, and the centripetal word is used here, but it wasn't in the index. I mean, that's not how people are going to know it, I guess. Okay, anyway. The reaction due to the inertia of the moving ball offers resistance to the centripetal pull and tends to break the string. I don't know what that's. If the string breaks, the ball immediately begins to move in a straight line along a tangent to the curved path. The resistance that a moving body offers to deflection from a straight line is commonly known as centrifugal force. Some physicists object to the use of the term force as applied to the tendency a body offers to resist being deflected from its path. But beginners find it easier to think of such reaction as centrifugal force, in italics. Now, were they trying to say that, well, it's not a force, but we're going to talk about it as if it were a force because it's easier to understand that way? That seems like a little obfuscation right there. What are some they still what they have to they acknowledge it though they're contradictory even. What are some illustrations of centrifugal force? Mud flies from a rotating carriage wheel when the centrifugal force exceeds its adhesion to the tire. Now, how could mud fly off of a tire if there was no outward force? No force compelling it outward from rotation. Mud is flung off the tire by the centripetal force pulling on its mass because it's mass that's at the distance of radius and rotating that creates the force swinging outward. So it takes the mass though. Look at a whirlpool. A whirlpool is hollow in the middle because the mass goes to the outside because the mass is being acted upon and moving outward. A tornado is hollow and the heavier elements in it or out the outside. It moving slower. Okay, so where was that? Water flies off at a tangent from a rapidly turning grindstone. David knew that a high velocity could be imparted to a missile by putting it in a sling. I didn't know David used a missile on Goliath. By putting it in a sling and whirling it around his head. That knowledge and his skill in controlling the direction of the stone which he picked out of the brook made him the conqueror of Goliath. Emery wheels sometimes burst when driven at high velocity. The centrifugal force exceeds cohesion. An automobile rounding a curve at high speeds is likely to turn turtle. Whatever. How can we counteract the effects of centrifugal force? And so we're trying to counteract something that doesn't exist. We lean towards the center when we are skating around a curve to prevent the overturning of a train rounding a curve. The tracks are so banked that the rail on the outside of the curve is higher than the inside rail. Running tracks in a gymnasium and race tracks of all kinds are banked at curves to help nullify the effects of centrifugal force. Some of our new highways are banked at curves to help prevent accidents. Since centrifugal force depends upon inertia, and inertia is a general property of all matter, we cannot do away with centrifugal force, but we can in some cases prevent damage by nullifying its effects. We're nullifying the effects of the non-existent force now. What are some practical applications of centrifugal force? In former years, farmers let the milk stand until the milk rose. Oh, it's the milk and cream separator. Until the lighter cream rose to the top of the pan or crock. Then the cream was skimmed off the top of the milk. Now centrifugals are used to separate the cream from the milk. The milk enters the top of the separator and is thrown against the surfaces of several funnel-shaped discs or blades that rotate at a high speed. The cream, which is lighter than the milk, rises along the top surfaces of the blades and issues from an opening near the center. The skim milk passes to the outside of the rotating blades where it is drawn through a separate outlet. There's the example. Because it's more dense and it goes to the outside because it's where the mass is at. James Watt devised a governor to regulate the speed of a stationary engine. It is operated by a belt driven from the shaft of the flywheel of the engine. As the speed increases, the two balls move farther apart. Here. Since centrifugal force increases with the speed, as they move outward, they lift one end of the lever which shuts off some of the steam. The reverse occurs when the engine begins to slow down. Some automobile speedometers are operated on a similar principle. Small weights are hinged to a shaft which is driven through a flexible cable by means of a gear attached to the drive shaft or to one of the wheels. As the speed increases, these weights pull outward and move the pointer over a graduated dial. Wet solids may be partially dried by putting them in a perforated cylinder, which is then rapidly rotated, like in a clothes dryer. The water is thrown out through openings. Crystals are dried in this manner. Laundries also use this method for drying clothes. Some types of electric washing machines use a centrifuge for drying clothes. A very efficient type of water pump depends on it for its action as a centrifugal force. As the rotor turns rapidly in the direction shown by the arrows, the water is forced by the rotating blades through the discharge pipe. Liquids that contain sediment are often centrifuged instead of being filtered. The sediment from varnish is removed by this method. In making rayon, the solution of cotton must be passed through openings of tenths, hundredths, at 5,000ths of a millimeter in diameter. As the solution of cotton flows into the solution of sodium hydroxide, a fiber is formed. It takes 20 of the small fibers thus produced to make a single thread of the silk. Since these openings are so very minute, the solution is centrifuged at 8,000 or 10,000 revolutions per minute. Before spinning, in order to remove any sediment that might clog openings. Even our amusement parks utilize centrifugal force. At Coney Island, the human pool table is an example. The whip and the loop-the-loop, etc. are other examples. How can we calculate the magnitude of centrifugal force? It is possible to measure the pull which the ball of figure 211 exerts upon the string. If we use a ball which has just double the mass, the pull on the string will be just twice as great. Hence we conclude that the centrifugal force is directly proportional to the mass and the radius in the case of a rotating body, I would add. If we shorten the string, the ball is pulled from its path faster and it reacts with greater force to break the string. Careful measurement shows that the centrifugal force is inversely proportional to the radius of the curvature. As we swing the ball faster so that the velocity along the curve increases, it pulls more strongly on the cord. Accurate measurements show that the centrifugal force is directly proportional to the square of the velocity. If the v equals velocity in centimeters per second and the mass in grams and r the radius in centimeters, then CF is equal to mass volume squared over radius. In the English system, with pounds. A ball that weighs 10 pounds is being rotated by means of a cord 4 foot long. If its velocity is 20 feet per second, find the force in pounds that tends to break the cord. Oh, it's the centripetal force pulling inward to your hand that breaks the cord, or whatever's holding it, not the outward force of an imaginary centrifugal. Oh, that's ridiculous. Come on. Okay, I'm almost done. What is the principle of the gyroscope? Everyone is familiar with the toy gyroscope and the spinning top. The centrifugal force of a heavy rotating wheel gives it great stability. When such a wheel is rotating rapidly in a certain plane, considerable force must be used to change the plane of rotation. The principle of the gyroscope has been put to practical use in many ways. The Sperry type of stabilizer used on airplanes depends upon the principle. A gyroscopic compass is now used on all submarines. The flywheels on the engines of a steamship are mounted on the axes that extend across the ship, thus they tend to prevent the rolling of the ship. The Italian liner Conte di Savoia is equipped with gyroscopes. The direction of a torpedo is also guided by gyroscopes. There's a whole lot of references to centrifugal force there, although they did preface it with a way of that it's describing it, but then they say they can't get away from it. And I'm sure Professor Dave and several others and the Science Asylum guy who likes to yell science at you, and he's got a real bullying attitude, the way he describes his centrifugal versus centripetal video, the way he talks in it. His mannerisms and his gestures are all, you're an idiot if you don't believe this, here's how simple it is, and he's trying to ram it down your throat is what it seems like. But centripetal was made up by Newton to support gravity, because gravity wasn't doing it on its own. Thank you. Guess that means we're finished off now. Okay, thanks for watching. Yeah. Centripetal, centrifugal.